volcano off the BC coast is primed to erupt soon.
It's nearly 500 kilometers off the coast of Vancouver Island, so it's well offshore, and it's a deep volcano.
Billions of dollars worth of critical minerals at the bottom of the seafloor. But extracting these minerals via deep-sea mining is a divisive idea.
Rising at the edge of the continental shelf, where British Columbia's mist-laced forests blur into a horizon of ever-shifting water, lies a domain as silent as it is profound. Here, under the cold Pacific, light fades quickly. Above, the world walks forests ancient as myth, while below, in that secret dark, pressures unimaginable shape the Earth's ongoing story. For centuries, the waters off Vancouver Island have been known for violent winter storms, for the gentle migrations of salmon, for the silent glide of orcas along kelp-shadowed passages. But in June 2025, scientists revealed a discovery in these depths that reframes all such surface narratives. With new generation remote submersibles, researchers traced a disturbance on the ocean floor, a structure, bulbous and massive, ringed by mineral flows and curling plumes. It was here, off the west coast of Canada, where the Pacific's tectonic heart pulses, that they found it, a seemingly dormant underwater volcano, its summit lost beneath 2 miles of pressure and salt. But dormancy, it turns out, need not mean silence. Within a field of fuming ridges, cameras captured an astonishing sight. Millions, literally millions, of colossal eggs, each one larger than a football, clustered in the superheated shallows of the caldera, their pale shells trembling with nascent life. This remarkable observation was just the beginning. Samples gathered from the site brought to light a new, enigmatic substance, Ehrigite, a mineral previously unknown, containing bismuth and tellurium in a combination not found elsewhere, and with properties that could reshape the prospects of resource industries. And deeper still, among the sediments, lay the elegant form of a long-lost creature, a fossil so strange it spurred the description of a new species, Traskasaura sandrae, challenging paleontologists to expand the known boundaries of ancient life from this region. What then do we truly know about the world beneath British Columbia, now that the ground itself seems alive with change, now that eggs stir, minerals glimmer with promise, and vanished lives leave their imprint in stone? And what does it mean when science, peering into the Pacific's abyss, returns not only with marvels, but with warnings of awakening cataclysm, a chaos capable of reshaping coasts from California to Canada? The hidden caldera, Dormancy Redefined. To speak of a dormant volcano is to rely on a fiction woven by the limits of human time. Centuries may pass without an outburst, a quiet so convincing that navigators, fishers, even scientists themselves mistake stillness for death. But in the vast spaces of the underwater realm, dormancy is only a pause between chapters, a careful inhale before the drama resumes. Off Vancouver Island, where the ancient Cascadia subduction zone threads below the ocean floor, seismic vigilance is an article of faith. Here, the very bedrock is restless, always shaped by deep tectonic processes. The volcano, first glimpsed in sonar as a gentle dome amid jumbled terrain, appeared harmless, lacking the classic threat of Pacific Rim giants like Mount St. Helens or Shasta, its slopes mantled by layers of sediment and the quiet labor of bacteria. But sonar cannot reveal all. The first sign came as a local anomaly, venting in patterns like exhalations, water temperatures that rose just slightly, shifting concentrations of mineral-rich gases ascending in drifting columns. Yet, when a deep-sea rover descended in June 2025, the truth revealed itself in a mosaic of heat and light. Not just new venting, but a whole field of new creation. Millions of enigmatic eggs anchored between blackened stones, around which the water shimmered. Unborn life, sheltered in the warmth of volcanic breath. As scientists mapped the dimensions of the caldera, they recognized the real scale of its sleeping power. Unlike the singular cones of surface volcanoes, this formation pulsed with fissures and mounds, its chambers swollen with superheated water, its crust streaked by sulfur and rare metals. Every measure, each trace of carbon, each rise in methane, told a tale of internal pressure building beneath the weight of the ocean. Volcanologists, mindful of Pacific volcanoes' cycles of quiet and violence, acknowledged in this underwater system the possibility of unpredictable renewal and change. So what does this mean for those who dwell above, unknowing, atop the forests and coasts of British Columbia? In the language of geologists, dormancy is a spectrum, not a guarantee. If this submarine volcano stirs, what new world might it reveal? What boundaries might yield to geologic force? A nursery in the deep, the eggs that startled science. The footage, when first broadcast from the rover's feed, stilled the usual chatter of marine biologists into awed silence. Illuminated by artificial lights, the eggs were astonishing, round and silvery, some slightly opalescent, others marked by fine striations, and all remarkably oversized. They nestled in flows of tepid water, packed close as pebbles, forming swathes that looked, from a distance, almost like snow-buried boulders. No known animal, no cataloged squid, jelly, or deep-water fish produces eggs of such size or in such density within this environment. The clusters extended for hundreds of meters along the volcano's flanks, a vast nursery where few expected any life to start. Some eggs seemed to pulse gently, their membranes catching the lights in subtle, shifting patterns, signs of metabolic activity fed by the hydrothermal chemistry of their volcanic birthplace. Speculation swept the scientific community. Were these the spawn of an undiscovered species, perhaps a deep-sea giant, adapted to the unique warmth of hydrothermal vents? Did they hatch in cycles, timed with changing conditions, each period of volcanic warmth prompting an oasis of reproduction unseen elsewhere? Or were these moments of mass spawning a reminder of how little we still grasp about the ecology of these dynamic undersea landscapes? Yet more mysterious was the possible connection between the volcano's stirring and the egg's abundance. Could the restlessness below, rising magma, vented heat, shifting crust, trigger life at a scale never before witnessed? Scientists, parsing footage and sample data, were forced to consider that the same edge between eruption and calm might support unlikely life, but also threaten it. However, while speculation is tempting, the only fully verified facts are the eggs' presence and their numbers. Their origins, cycles, and dependence on volcanic activity await further research and confirmation. The eggs and their abundance thus serve as both marvel and local mystery. Are they evidence of hidden ocean fertility or indicators of a balance on the edge? If the volcano awoke, if heat and gas surged dramatically, could all this life vanish overnight? With caution and awe, biologists continue to study these findings, careful to ground each claim in what the evidence shows. Ehrigite, a mineral's promise and peril. Even as cameras lingered on the nursery, the submersible's robotic arms harvested something else. Unusual nodules with geometric facets and metallic colors. Onshore analysis rapidly revealed something unprecedented. The mineral was new and would come to be named Ehrigite, composed of bismuth and tellurium, elements seldom found together in such form. Its potential significance for science and industry was immediately recognized. In the modern world, finding new mineral resources, especially those containing strategic elements like tellurium and bismuth, carries large implications. Tellurium is valued in the production of solar panels, bismuth in electronics and other advanced technologies. Ehrigite, with properties distinct from either element alone, suggests new possibilities for renewable energy or improved electronic materials. The reveal generated excitement within geology and industry circles, but also debate. A rich mineral deposit, especially one hosting such rare elements, could reshape supply chains and commercial strategies. Yet, as the expedition's findings illustrate, the site is not simply a mineral cache. It is an environment rich in biological and geological wonder, a place where rare minerals, unexplained eggs, and fragile ecosystems coincide. Mining in such a dynamic setting is fraught with hazard and uncertainty. The volcano is not inert. Measurements indicate active venting, temperature gradients, and chemical flux. History and recent data make clear that submarine volcanic environments can change rapidly and are subject to catastrophic failure. Extracting minerals here would demand rigorous risk analysis, ethical consideration, and, above all, caution. There are also enduring questions. Would large-scale extraction threaten the integrity of the ecosystem or even the stability of the volcanic structure itself? Could it, as one expert considered, trigger or worsen undersea geologic hazards with regional consequences? The allure of Ehrigite glimmers with promise, but simultaneously warns of the price of haste. Traskasaura sandrae, an ancient creature unearthed. While the robots probed the site around the Caldera's rim, they recovered a slab of shale harboring the fossil of a previously unknown sea creature. Later named Traskasaura sandrae, the fossil revealed a species unrelated to any modern animal, distinguished by unique anatomical features, neither fish nor crustacean, but something altogether singular. This discovery gained quick attention among paleontologists. The characteristics of Traskasaura sandrae, its size, body shape, and symmetry, compelled researchers to reconsider the region's evolutionary history and the diversity of life in ancient Pacific ecosystems. The significance of finding a new species in these marine sediments is clear. Fossils recovered from such depths offer rare insights into past environments and lineages. They also hint at the vastness of what remains unknown about life hidden within the oceanic crust and undersea volcanic provinces. Yet, as with the eggs, the fossil's fate is intertwined with that of the volcano itself. Renewed activity or collapse could obliterate such natural archives, destroying records of past life. In this way, each glimpse of the unknown is shadowed by the threat of erasure, a reflection of geology's indifference to preservation. Signals in the water. Awakening unrest. As summer deepened in June 2025, scientists monitoring the underwater volcano observed changes in its patterns. Vent temperatures fluctuated, chemical signatures of methane and sulfur shifted, and subtle echoes in the water hinted at ongoing adjustment within the Earth. These changes triggered concern and vigilance among experts familiar with the Pacific Rim. While eruptions above water offer visible prelude, rising fumaroles, billowing steam, undersea, forewarning can be obscured. Instruments may register only minor tremors or odd drifts in current and chemistry, while the real drama unfolds in secret. What might an eruption here entail? Submarine volcanic events can briefly alter the shape of the seafloor, create local plumes rich in minerals, and affect marine life. On rare occasions, they result in disturbances or tsunami-like waves with coastal effects. Compared to major subaerial eruptions, the direct impact on human settlements may be reduced by depth and distance. Yet the scale and novelty of this system keep vigilance at the fore. The eggs, the new mineral, and the fossil all are testament to a system balanced between creative forces and destructive potential. The lesson from across the Pacific is clear. Apparent quiet does not guarantee safety, and close monitoring is essential. Carbon, catastrophe, and the wider world concurrent with these discoveries. June 2025 brought a new planetary milestone. Analyses of atmospheric samples showed global carbon dioxide concentrations rising past 430 parts per million, a record without precedent in human times. Climate scientists warn that to stem the mounting impacts of warming, emissions must soon drop by more than 7% per year on average. Yet progress remains slow. The awakening or eruption of an undersea volcano, while not a driver of long-term climate, can interact with such atmospheric changes. Large volcanic eruptions are known to temporarily cool the planet by injecting reflective sulfur aerosols. but the persistent release of greenhouse gases from small but frequent volcanic events can contribute, albeit modestly, to natural emissions. If a significant eruption occurred in a period already defined by high CO2, the interplay of ocean chemistry, weather, and marine biodiversity could be complex. Currents may shift, sea life may adapt or struggle, and environments like the deep-sea nursery may vanish. Major volcanic events can have far-reaching cascading consequences, but most relevant to these findings is that any disruption to the underwater volcano could erase a newly discovered ecosystem before it is fully understood. Measured risk, extraction, and ethics at the edge. News from the expedition quickly occupied Canadian headlines with talk of a hidden nursery of millions of giant eggs. Mining executives studied early reports on Ehrigite and its potential for energy technology. International consortia began to discuss the future of deep-sea resource extraction, knowing past attempts had left environmental scars lasting generations. A dilemma emerged. The world needs critical minerals to accelerate the transition away from fossil fuels. Yet the costs of resource extraction, especially in fragile or unique habitats, are enormous. The rare mineral deposit, the nursery of giant eggs, the window onto ancient life. These are not merely resources to count and measure. Each represents values impossible to summarize in profit and loss, values that intersect science, conservation, culture, and future generations. Any approach to managing such a place must weigh more than market forces. In the past, unchecked rushes to exploit new deposits resulted in damaged environments and lost opportunities for science and stewardship. Here, the risk is still greater. The site's uniqueness could be lost to both natural catastrophe and human haste. Across Canada and internationally, conversations now focus on how to safeguard this site for science and posterity. Some propose strict no-mining zones, others global research stewardship. All acknowledge that time is short and the challenges are great. Above all, the volcano's own unpredictability remains the key variable. Whether protected, studied, or left undisturbed for now, the fate of all below is ultimately tied not to policy alone, but to the rhythms of the Earth. Echoes from the Ring of Fire. The story unfolding beneath British Columbia is part of a wider Pacific drama. From the Aleutian Arc to California's ridges, the Ring of Fire is a chain of restive forces. Volcanoes, earthquakes, shifting slabs of crust. Each link is unique, yet all are connected by the slow, patient mechanics, plate tectonics, and the cycles of birth and destruction carried across millions of years. In Alaska, magma builds beneath mountains. In California, faults buckle and slip. Along the coast, life and death are written in flood and fire as well as calm. The underwater volcano off Vancouver Island is a new chapter in this living saga, a chapter whose implications for science, safety, and our collective imagination have only begun to unfold. In all these places, the themes recur. Quiet can be deceiving, and the most vital clues to future change may come hidden in cold water, slight chemical anomalies, or the unexpected emergence of new life. Discovery here is not just about science, it is about listening to the restless earth. The mountain, the sea, and the unknown. Within British Columbia, the news of a living, shifting volcano, nest, mineral trove, and fossil archive together raises questions old and new. In towns and on reserves along the coast, people consider not only emergency planning, but how to relate to the unquiet earth beneath them. Is the volcano threat or opportunity, teacher or hazard? Is our role to study and protect, to wait and learn, or to risk and extract? The stories of First Nations echo through these debates. Traditions of respect for dangerous places, knowledge of underwater fire, and memories of places best left untouched. Children marvel at the rover's dramatic images, the eggs as round as moons, the strange shine of Ehrigite in artificial light. Conversation grows as families, teachers, and elders try to frame the meaning of such discoveries. What should we do when confronted with such vulnerability and promise so close to home? Emergency planners ask hard questions. What risks do submarine eruptions pose to infrastructure? to fisheries, to coastal towns. How much can be monitored and how much must simply be watched with care? What is clear is that every new report, every update from the research vessels above the volcano heightens both curiosity and urgency. A nursery of unknown creatures, a mineral with revolutionary potential, a fossil signaling lost worlds. Each is a challenge to complacency and an invitation to be wiser. The new unknown, watching the waters. As June turns and the northern summer stretches dusk along the coast, the volcano beneath British Columbia continues its slow evolution. Drones patrol, sonar maps, sensors probe and analyze. The fate of the nursery, the potential of Ehrigite, the significance of Traskasaura sandrae, all remain unresolved. Scientists do not claim triumph. Rather, there is humility, the humility bred by every volcano that has ever surprised the world. Data accumulates, is compared with historic precedent, and models are refined. Each reading of rising vent gas or shifting current is a prompt for more research, more care. So what is our role now that these wonders have surfaced? The future of the eggs, of Ehrigite, and of Traskasaura sandrae is uncertain. Vigilance is demanded, exploitation remains possible, and disaster stands as an ever-present risk. Beneath all these is a demand to listen, to notice, and to respect the true depth of the unknown. Perhaps in the end, this story is not just about the forces that move beneath the sea, but about the decisions we make above it. Will the nursery be preserved? Will minerals be wisely managed? Or will haste obscure the lessons of the deep? The earth writes its own script. Our place within it is never as secure or as permanent as we imagine, but it is rich with possibility if we approach with curiosity and care. If this story has sparked your curiosity, let's keep the conversation open. When we learn of mysteries under our feet, eggs waiting to hatch, new minerals waiting to be understood, ancient life only now coming into focus, what future will we choose? Is wonder enough, or does revelation demand responsibility, action, and stewardship? Thank you for joining this journey into the Pacific depths. Remember, the world beneath is not as distant or as silent as it seems. Every discovery is a dialogue. Every question, if pursued, the start of a new story. Stay curious, stay vigilant, and never forget how much remains to be uncovered and protected.